Hello. Yes, we welcome you back to PSSB, uh, Physical Sciences Silver Bullet, and we're having the question at hand. Don't forget to subscribe, and please don't be selfish. If the video has been useful to you, please click the like button. Elana designed an experiment for electroplating of necklace with chromium using chromium nitrate as the electrolyte. So the first question comes, define electrolyte. So what is an electrolyte? Okay, an electrolyte is a solution or molten substance which conducts electricity by movement of ions. Okay, so let's put that one down. Okay, that is that. Then comes another question, 4.1.2. It says, define a cathode. So what is cathode? Cathode is an electrode at which reduction takes place. Let's put that one down. Okay, then comes this question. It says, identify what each of the following is made up of in this setup. 1, anode, and 2, cathode. So to answer this question, let us go through this journey. It's just a sketch. What we know about this electroplating is that one of the electrode is going to be the necklace. Suppose this is our necklace. And the other one is going to be this electrode. We are going to find out what it is. So there are some basic principles which must be understood about electroplating. The principles are that if you want to electroplate this necklace, with chromium, this one must be chromium. Okay. Another basic principle is that this electrolyte must be a soluble salt of chromium. Okay. Preferably chromium nitrate. Okay. Another basic principle, which is very important, is that the ions are moving from this chromium metal towards the necklace. So these ions are the chromium ions. Now I want you to know that this arrow gives you all the information you need about electroplating. You have to remember, what is the purpose of electroplating? Is for the metal to be coated here on our necklace. So whatever you want to coat here, the ions are moving towards it from the other electrode. Remember, we don't know which one is anode, we don't know which one is cathode. But remember, we know something. What do we know? We know that in accordance to the mechanism of conduction of ions, positive ions move towards negative electrode, and the negative ions move towards positive electrode. That's the mechanism of conduction. So if these ions are coming here to this necklace, so what is the polarity of necklace? The polarity of necklace is negative. It must have opposite charge to the ions which are coming to it. And I hope we know that if this is negative, the other side is what? Positive. So this is a negative, this is positive. Okay. Then we know something. What do we know? We know that for electrolytic cell, the positive is anode and the negative is cathode. And that is that. So to answer the questions above, which one is anode? Is chromium metal. And which one is cathode? Is the necklace. Okay, let's put those down. Okay, yeah, that is that. And then comes the next question, 4.3. It says, write the half reaction taking place at the anode. Remember, we know that the reaction taking place at the anode is oxidation. And what is being oxidized? Chromium metal is being oxidized to chromium ions. But now there is a trick here, and I want us to pick it from here. I want us to look at this. You have to remember that chromium is a transitional metal. It can adopt oxidation number 2, it can adopt oxidation number 3, and so many others. So this reaction, this compound, the formula tells us in which oxidation number is chromium. You have to remember that nitrate has valence 1, and the chromium can adopt several numbers. But for this compound, what is the valence of chromium? This number is for chromium. Because nitrate is 1. Nitrate, the 1 of nitrate is here. Remember, don't write 1. But the 3 of chromium is there. Why is it important? It's important because we are supposed to indicate number of electrons transferred. So it's going to be chromium solid being oxidized to chromium ions plus 3 electrons. This one, we'd get it from there. Okay, that's that. Then we go to the next question. Okay, it says, write the half reaction taking place at the cathode. We need to recall that the reaction taking place at cathode is reduction. And the question is, what is being reduced? Chromium ions. Chromium ions are being reduced to chromium solid, which is being attaching to the necklace. So that is that. Then the next question. So 4.4 says, state the changes, if any, undergone by the electrolyte. So how do you answer? Where do we see to get the answer to this question? We need to look at these two half reactions. Now, the moment you have these two half reactions, the reverse of the other, I want you to remember, look at what you have here. Chromium undergoing oxidation, and chromium ions undergoing reduction. So when you are finding the net of this reaction, you are going to get the net as 0. So the moment you have this scenario, you have to make a conclusion about the changes undergone by electrolyte. Okay. And what is the change? The change is no effect or no change. Okay, next question. So the question reads 4.5. Give a reason for your answer to 4.4 above. What is the answer? No change. The question is why? Okay, you have to, this one, the answer lies here. These two reactions will have proceeding at the same speed, the same rate. So what do we say? The rate of oxidation at the anode is equal to the rate of reduction at the cathode. Please mind the word rate. It's very important. So let us put down that. So that is that. And with that, we are going to close this video here. We thank you for your time. Don't forget to subscribe if you haven't done so. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. See you next time. Bye-bye.